For quite a long time, researchers have been keen on investigating space to uncover what lies beyond our planetary group. However, the discovery of Oumuamua shocked cosmologists, as they were unsure if it was an alien spaceship, a comet, a space rock, or a totally unclassified article. In an unforeseen new development, Oumuamua has suddenly appeared once more and is sending signals to Earth. What does this secretive sign imply? Are we facing an alien intrusion? Join us on this enrapturing journey as we unwind the mystery behind Oumuamua's return and these peculiar new signals. Just a short time after the discovery of Oumuamua, an Israeli-American theoretical physicist created a ruckus with the publication of his groundbreaking book, Extraterrestrial. He proposed a stunning viewpoint, arguing that Oumuamua was, in fact, a particle sample shipped off our planet, with the mysterious flying object being named a courier from afar. You would anticipate the science community will embrace its extraterrestrial origin, but it's more perplexing than that. That's why, before delving into the reasons for Oumuamua's unexpected return and the messages it's conveying to Earth, we need to explore its nature and origin. In the harvest time of 2017, Robert Warwick discovered Oumuamua using the Pan-STARRS telescope at the Haleakala Observatory in Hawaii. The appearance of this peculiar flying object set off a significant upset in how we interpret space. But what makes this object truly exceptional is that it's not Earth's first encounter with an unidentified celestial object. In fact, Earth observers report thousands of UFO sightings each year. However, not all of them are confirmed. Oumuamua, however, stands out as one of the most captivating and mysterious of all. When you hear the term UFO, you might imagine flying saucers piloted by extraterrestrial beings with large oval heads and slim bodies. However, the reality is more nuanced. A UFO, or Unidentified Flying Object (UAP), serves as a broad term encompassing any unusual flying object that hasn't been previously identified or classified, potentially originating from beyond our planet. It could be a space rock, astronomical debris, or even an alien spacecraft. The discovery of Oumuamua represents a long-awaited moment for scientists. For many years, they had speculated and eagerly anticipated such an earth-shattering event, aiming to solidify their belief in the existence of celestial bodies beyond our immediate planetary group. Now they have unmistakable, unquestionable proof that the universe extends far beyond the confines of our solar system. However, Oumuamua blew some minds. While scientists had expected a more traditional round or irregularly shaped celestial body, Oumuamua's unique properties set it apart. Upon initial assessment, astronomers likened its shape to a cigar or perhaps a pancake. Its size was relatively modest, measuring around 3,377 feet long, 364 feet in width, and 62 feet in thickness. While significant for an interstellar object, it's relatively compact. The narrative of Oumuamua's discovery is as arresting as the object itself. On October 19, 2017, astronomers identified this strange object drifting through our planetary group. By then, Oumuamua had been traveling for 40 days since its closest approach to the Sun and was a staggering 21 million miles from Earth, creating a considerable distance from our star. To put this into perspective, that distance is approximately 85 times the range between the Moon and Earth. When Oumuamua was first discovered, the International Astronomical Union initially designated it as 1I 2017 U1, initially suspecting it was a comet. Later, it was found that the object had no comet's tail. However, the asteroid classification also missed the mark, and once its extraterrestrial origin was unequivocally established, the name Oumuamua began to gain notoriety. This name reflects the belief that it's a visitor from space, which became even more apparent upon its return, where it began emitting perplexing signals to Earth. These signals were received by strategically positioned telescopes on Earth. After its initial visit, data regarding Oumuamua's trajectory was obtained through instruments like the Pan-STARRS 1 telescope, part of the Space Surveillance Network, the Canada-France-Hawaii Telescope (CFHT), the Very Large Telescope (VLT), and the Gemini South Telescope in Chile, along with the W.M. Keck Observatory in Hawaii. Oumuamua, being both small and faint, posed a considerable challenge for observation, especially as it was already millions of miles away when first sighted. In fact, it slipped through the cracks in stereo high 1A observations close to perihelion on September 9, 2017. because its brightness had dimmed to an apparent magnitude of around 13.5. As it continued to recede from Earth, it became increasingly difficult to see. By the end of October, its brightness had faded to an apparent magnitude of 23, rendering it virtually invisible to the naked eye. Oumuamua's unusual trajectory provides insight into its true capabilities. With an orbital eccentricity measuring around 1.20, it has the highest ever observed. But what does this scientific language mean? We should break it down. With an orbital eccentricity that high, Oumuamua can exceed the Sun's escape speed, rendering it unbound to our immediate planetary group. This suggests that it could ultimately leave our solar system and journey to other corners of the universe. This discovery confirms that Oumuamua is indeed an interstellar object, originating from beyond our solar system, millions of miles from our own. Few hypotheses have been proposed by researchers to make sense of the origin of this mysterious object. Let's explore these ideas individually as we dive further into unraveling the secrets surrounding Oumuamua. Is Oumuamua a comet? Oumuamua's presence in our celestial neighborhood has enthralled researchers, revealing new discoveries and raising various explanations. Initially, researchers believed it might be a comet, but that idea was quickly debunked. Strangely, the theory of Oumuamua being a comet has recently re-emerged. So, what exactly is a comet? Comets are captivating celestial entities. They're essentially large interstellar objects made up of dust and ice that follow and orbit around the Sun. If you were to summarize their most prominent feature, it would undoubtedly be their long streaming tails. These large wanderers are often considered relics from the early days of our solar system, remnants left over from the chaotic formation of planets and stars billions of years ago. In a way, they're like time capsules of the universe, preserving a snapshot of a time when the Sun, stars, and planetary bodies were still in their cosmic cradle. However, what do these comets look like? Imagine them as massive bundles of dust and ice with a frozen core, aptly known as the nucleus. Typically, a comet's nucleus measures around 10 meters in diameter, which is quite significant, about the size of a small town. However, these cores remain frozen until they venture close to our Sun. As they approach our star, the Sun's heat transforms the cold core into gas, and this outgassing creates brilliant jets of gas and dust that trail behind the comet. The interaction between this gas and the accompanying dust creates a voluminous, dim cloud around the core, appropriately named the coma. You've probably seen artistic depictions of comets with their distinctive tails. In reality, comets usually have two separate tails. The dust tail, stretching for thousands of miles, follows a broad, gently curving path behind the comet, while the ion tail consistently points directly away from the Sun. In the past, Earth has been visited by several comets. These celestial visitors provide us with valuable insights into their composition and structure, offering clues about the workings of the universe. One such celestial traveler is Halley's Comet. This large comet spans around 15 kilometers in width and 40 kilometers in length. It follows an elongated orbit like many comets and circles the Sun about every 75 to 76 years. The last time we had the pleasure of seeing this heavenly wonder was in February 1986. However, this wasn't the first time Halley's Comet graced us with its presence. After its observation in 1682, English astronomer Edmund Halley, the comet's namesake, deduced that comets follow periodic patterns. He boldly predicted its return in 1758, a prediction that remarkably came true. There's even evidence that Halley's Comet appeared in the 1066 Bayeux Tapestry, highlighting its long-standing association with our planet. While Halley's Comet takes the spotlight, it's not the only comet to have passed through our celestial space. One less popular yet equally captivating comet is Shoemaker-Levy 9, which made an exceptional appearance not on Earth but on our neighboring planet, Jupiter. Researchers believe this comet split into 21 pieces, influenced by Jupiter's gravitational forces in 1992, ultimately colliding with the gas giant in 1994. This cosmic crash was witnessed from Earth and even from the Galileo space probe. The impact was estimated to be equivalent to the explosion of 6 million megatons of TNT, a truly astounding event. Then there's Comet Hyakutake, a frosty, blue wanderer with a faint tail. This comet is famous for putting on one of the most enthralling comet shows in recent years. In March 1996, it passed within 15 million kilometers of Earth, marking the closest it had come to the Sun in around 9,000 years. This encounter was remarkable not only for its closeness but also for its ability to bewilder researchers as it crossed interstellar space. Comet Hyakutake released X-rays at levels 10 times more intense than expected. In 1996, the Ulysses spacecraft accidentally wandered through the comet's tail. This impromptu encounter revealed that this celestial marvel stretched over an astonishing 600 million kilometers, making it one of the largest comets ever observed, almost 2 times the length of any other known comet. These are just a few notable examples in the grand cosmic parade of comets. Other comets, such as Hale-Bopp, Comet Borrelly, Comet Encke, and Comet Tempel-Tuttle, have also made their mark in our celestial record. The interest surrounding Oumuamua has prompted several researchers to reconsider their initial conclusions. Jennifer Bertner and Darl Seligman, as mentioned earlier, have returned to the idea that Oumuamua may be an interstellar comet. Their theory suggests that, despite its curious shape, somewhat small size, and distinct flight pattern, Oumuamua could indeed be a comet of interstellar origin. While most comets are rich in ice and release copious amounts of water vapor, gas, and dust when approaching the Sun, Oumuamua acts differently. Observations of Oumuamua didn't reveal the typical comet tail, which raised questions about its classification. However, Bertner, drawing from her extensive expertise in cold space objects, proposed a novel explanation. She hypothesized that Oumuamua could have expelled hydrogen gas into space, giving it an unusual acceleration. This curious mode of propulsion can be attributed to the radiation that permeates outer space. When this radiation interacts with the water ice on Oumuamua, it produces hydrogen, which becomes trapped beneath or within the object's surface. When the Sun's energy strikes Oumuamua, it triggers the release of this hydrogen gas, propelling the object with considerable speed. While this theory appears to be one of the most plausible explanations, it's by no means the most intriguing. Are you ready to delve into the strangest theory about this flying object? Could Oumuamua be a piece of an exploded planet? 2 astrophysicists at Arizona State University, Alan Jackson and Stephen Desch, put forward one of the most widely accepted theories regarding the origin of Oumuamua. Their theory, considered one of the most robust explanations to date, suggests that this unconventional, pancake-shaped celestial object originated from a distant planet in another planetary system, millions of miles from our own. They hypothesized that an asteroid crash with that unknown planet in the distant past caused a piece to break free and embark on a massive journey through space. Astronomers determined that this object didn't originate within our planetary system by meticulously analyzing its trajectory. When it was detected in our planetary system on October 19, 2017, it was well on its way out of our celestial neighborhood, venturing into the vast reaches of deep space as part of its incredible journey. Through the vast universe, Oumuamua made a brief pit stop on our green Earth, serving as a core that alluded to the existence of other worlds beyond our own. However, the real intrigue lies in the discovery that Jackson and Desch have not only pinpointed a possible source for this bizarre object but have also managed to infer the nature of the planet. Jackson and Desch's theory suggests that the fragment of the exploded planet that became Oumuamua likely originated from a region of that planet where water was abundant. This conclusion is drawn from the presence of water ice detected on Oumuamua. The existence of water ice on Oumuamua was confirmed through observations that revealed its unusual brightness variations, which are consistent with the presence of water ice on its surface. This finding is significant because it provides clues about the composition and environmental conditions of the planet from which Oumuamua originated. Furthermore, the absence of any significant outgassing or coma typically associated with comets supports the idea that Oumuamua is not a comet but rather a fragment of a rocky planet. This absence of cometary activity suggests that Oumuamua is likely composed of rocky materials rather than volatile ice. The peculiar shape of Oumuamua, resembling a pancake or cigar, further supports the hypothesis that it is a fragment of a larger object rather than a conventional comet or asteroid. The implications of Jackson and Desch's theory are profound. If Oumuamua is indeed a fragment of an exploded planet, it provides compelling evidence for the existence of planetary systems beyond our own and the potential for catastrophic events to shape their evolution. The discovery of Oumuamua challenges our understanding of the formation and dynamics of planetary systems and opens up new avenues for research into the origins of celestial objects. In conclusion, the mystery of Oumuamua continues to captivate scientists and the public alike. Its unusual properties and enigmatic origin challenge our current understanding of celestial objects and their journeys through the cosmos. As researchers delve deeper into its secrets, Oumuamua serves as a reminder of the vastness and complexity of the universe, prompting us to question what else may lie beyond our reach in the depths of space.